In this video, we're going to be solving the second part of the 2019 Maths Jamb past questions. Let's go. Question 41 says, simplify this expression to two significant figures. So what we have here is 0.0839 multiplied by 6.381 divided by 5.44. And if you evaluate this using your calculator, you have 0.098413 as the answer. Now, when you are requested to show your answers in two significant figures, they are talking about the first two figures that are non-zero numbers, not two decimal places, which should have been 1, 2, but two significant figures. That means we're going to ignore the 0 here. We're going to ignore the 0 here. This 9 is the first non-zero number. That's the first significant figure. And 8 here is the second non-zero number, which is the second significant figure. But the next one, which is 4, is not up to 5, so we cannot round up our number here. So our final answer to two significant figures is 0098. And the answer here is D. Question 42 says, find the value of x and y in the simultaneous equation 3x plus y equals 21 and xy equals 30. So equation 1 is 3x plus y equals 21, and equation 2 says xy equals 30. So let's use the substitution method here to solve the simultaneous equation. So from equation 1 here, if we make y the subject of the formula, we'd have that y is equal to 21 minus 3x. So now that we have y here, we can substitute y into equation 2 and then solve for x. So if we do that, equation 2 here becomes, we have x multiplied by y, that will be 21 minus 3x equals 30. So if we expand what we have here, we have x multiplied by 21 is 21x, and x multiplied by minus 3x is equal to minus 3x squared equals 30. So we can rewrite this in a quadratic equation as minus 3x squared plus 21x. And if we bring 30 into the fold here, that's minus 30 equals 0. Ordinarily, from this step, we can tell that we're going to have two sets of answers because quadratic equations always have two solutions. So we'll have two x's, and for each of those two x's, we'll calculate two y's. So to solve this quadratic equation, to make our lives easier, let's just divide through by minus 3. If we divide through by minus 3 here, we'd have our quadratic equation as minus 3 cancels out minus 3 here to give us x squared. Minus 21 divided by minus 3 becomes minus 7x. And minus 30 divided by minus 3 becomes plus 10 equals 0. So we can go ahead and solve our quadratic equation. Now to solve quadratic equations, what you do is you take the coefficient of x squared here, in this case 1, and you multiply it by the constant figure here, which is 10. In this case, 1 times 10 is 10. So we write down the factors of 10. The factors of 10 are 1, 2, 5, and 10. Now we consider these factors and look for any two of these factors, which if we combine them, and by combination I mean if we add them or subtract them, would result in the middle term here. So in this case, if we have minus 2 minus 5, that will result into minus 7. So these two, which is, we're using 2 and 5 here, so we can substitute minus 7 for minus 2 and minus 5 in this equation. So if we do that, we'll have that x squared minus 2x minus 5x plus 10 equals 0. So all we've done is just substitute minus 7 for minus 2 minus 5 here. So now we can factorize our equation. So that will be, in this case, if we consider these first two numbers, x is common to both polynomial. So we write x outside of our bracket. So x squared divided by x is equal to x, and minus 2x divided by x is equal to minus 2. Now we come here, minus 5 is common to both terms. So we write minus 5 outside of our bracket. And minus 5x divided by minus 5 is equal to x, and 10 divided by minus 5 is equal to minus 2. At this stage of solving the quadratic equation, you will notice that you always have the same thing in the bracket here. So in that case, we can write down the common factor here, which is x minus 2, and then we'll write out the external numbers here, which is x minus 5 equals 0. So in this case, if you have that a, b equals 0, then you know that, because you know that anything multiplied by 0 is equal to 0. So either a is equal to 0 or b is equal to 0. So if we apply the same thing here, we'll know that either x minus 2 is equal to 0 or x minus 5 is equal to 0. And if we make x iterator formula here, we mean that x is equal to 2 here, or x is equal to 5 here. So now we have the two values for x. All we have to do is put these values in either of these two equations, and we'll get the values for our y's as well. So if we just make space here, so for the first value of x, which is equal to 2, so when x is equal to 2, if we use this equation, then our y is going to be equal to 21 minus 3 multiplied by 2. And this is equal to 21 minus 6. So y is equal to 15. And for the second case, when x is equal to 5, so y is equal to 21 minus 3 multiplied by 5. So this is 21 minus 3 times 5 is 15. So y is equal to 6. So our answers are that when x is equal to 2, y is equal to 15. And when x is equal to 5, y is equal to 6. And the option that corresponds to that answer here is C. So here they're saying that x is either 2 or 5. And in the corresponding cases, y is equal to 15 or 6. Question 43 says points x and y are 20 kilometers north and 9 kilometers east of point O, respectively. What is the bearing of y from x? Correct to the nearest degree. So if we assume this is our point O right here, and we're told that point x is north of point O and it's 20 kilometers away. So the distance between x here and O here is 20 kilometers. And we're told that point y is east 9 kilometers. So east is this direction here. So y will be somewhere here. And this distance right here is 9 kilometers. So if we complete our triangle, so we're requested to find the bearing of y from x. So what we're looking for is from x. From x here, we're requested to find the bearing of y, which is this angle right here. So if we call this angle small letter x. So how do we find this angle right here? Well, we have our triangle, and in our triangle, if we can find this angle right here, which we'll call angle theta, if we can find angle theta right here, we know that the sum of angles on a straight line is equal to 180 degrees. So if we know angle theta, then angle x degree is equal to 180 degrees minus theta degrees. So first, let's find theta. Now, how do we find theta? Well, let's go to our legendary SOHCAHTOA. Now, this is the angle we're concerned with. So we know that 9 kilometers right here is the opposite of this angle, and 20 kilometers right here is the adjacent. So what function here relates opposite and adjacent? And that's the tan. So tan theta degrees is equal to the opposite over the adjacent, which means tan theta is equal to opposite here is 9. So 9 divided by the adjacent, which is 20 here, 20. So that means tan theta is equal to 9 over 20 is 0.45. if we make theta the surrogate of the formula here, that theta is going to be equal to the arctan of 0.45. So if you use your calculator to evaluate that, you have that theta degrees is equal to 24.23 degrees. So now that we have theta x degree, so now we have theta right here. Now we have to compute our x degrees. So x degree is equal to 180 degrees minus 24.23, and this is equal to 155.77 degrees. So x degree is equal to 156 degrees. So our answer for this question is D. So question 45 says if P is equal to Q multiplied by R minus T divided by 15, all raised to power 1 over 3, then make T the surrogate of the formula. So we want to make T here the surrogate of the formula. So the first thing we need to do is to get rid of these major brackets covering here. So in this case, what we can do is find the cube of both sides here. So we raise both sides to the power of 3. So if we do that, we'll have that if you raise this side to the power of 3, this will cancel out this to give us 1. So the bracket is effectively removed. And this side will be P raised to power 3. So our new equation is P raised to power 3 is equal to Q R minus T divided by 15. So the next thing we need to do is multiply both sides by 15. So if you multiply this side by 15 here, 15 cancels out 15 here, and you have 15p cubed here. So our new equation is 15p cubed is equal to Q in bracket R minus T. So the next thing is to get rid of the Q here. To get rid of the Q here, all we have to do is divide both sides by Q. So if we divide both sides by Q, the Q here gets rid of the Q here. So our new equation is 15p cubed over Q equals R minus T. So now to get rid of the R here and leave the T alone here, we can subtract R from both sides of our equation. So if we do that on this side, plus R will cancel out minus R, and on this side we'll have minus R. So then our new equation is 15p cubed over Q minus R equals minus T. But what we have here is minus T, but we're looking for just T as the surrogate of the formula. So to get rid of this minus, we can multiply both sides of our equation by minus 1. So minus cancels out the minus here, and T times 1 still leaves us with just T here. And if we multiply everything here by minus 1 as well, so minus 1 times this gives us a minus sign here, and minus times minus here gives us a plus. So then our new equation can be written as, since we have a plus here, so R comes first, R minus 15p cubed over Q equals T. So this is our new formula with T being the subject. So the option corresponding to that answer here is B. Question 45 says, in the diagram above, O is the center of the circle ABC. Angle ABO is equal to 26 degrees, and angle BOC is equal to 130 degrees. Calculate the angle AOC. So if we assume that there's an imaginary line dividing this angle right here, so we're requested to calculate angle AOC, which is this angle right here. So how do we do that? Well, the first step is to recall a theorem that says that the angle subtended by an arc at the center of a circle is twice the angle subtended anywhere else. So the arc we're talking about here is arc BC, and the two angles subtended by this arc is the angle BOC and angle BAC. So the theorem says that the angle subtended at the center of the circle, which is this angle BOC, is twice the angle subtended anywhere else. In this case, angle BAC. So we know that angle BOC is equal to twice angle BAC. So if angle BOC is equal to 130 degrees, it means that therefore angle BAC is equal to 130 divided by 2. And that means this is angle BAC is 65 degrees. So this angle right here is 65 degrees. Now, if we assume that this angle, like we had said before, is divided by this imaginary radius. So if we divide these two into angle X and Y, it means that angle X plus Y is equal to 65 degrees. This angle X here, which is here to here, and this angle Y, which is from here to here, makes up 65 degrees. So let's go ahead and solve for this angle that we're requested to find. Now, first we have to find this angle X. Now, how do we do that? Well, if we know that this is the radius of the circle here, BO. Now, but we also know that AO is also the radius of the circle, which means that this triangle right here, angle ABO right here, is an isosceles triangle. Now, if two sides of the triangle are equal, that means the two angles here are also equal. So this is also 26 degrees right here. This angle is equal to this angle for an isosceles triangle. So if X is equal to 26 degrees, that means that from this equation right here, Y is equal to 65 degrees minus 26 degrees. And that means the angle Y is equal to 39 degrees. So now we know that angle Y right here is 39 degrees. So if angle Y here is 39 degrees, don't forget this is also an isosceles triangle of its own as well, because this side is equal to this side because they are both radii. That means this angle right here, angle ACO, is also 39 degrees. Now we have all the angles in this triangle except one, which is the angle we're requested to find here. But we know that the sum of angles in a triangle is equal to 180 degrees. So therefore, the sum of angles in this triangle right here is 180, which is equal to 39, which is this first 39, plus the second 39 here, plus the angle AOC we're requested to look for here, which we don't know yet. So this is going to be equal to 180 is equal to 39 plus 39 is equal to 78 degrees plus AOC. So from here, we know that AOC is equal to 180 minus 78 degrees, and that's equal to 102 degrees. So angle AOC right here is 102 degrees. So the answer that corresponds to that is D. Question 46 says, each of the interior angles of a regular polygon is 140 degrees. Calculate the sum of all the interior angles of the polygon. So if we have a polygon, any polygon at all, for example, let's take this hexagon right here. There's a theorem that says that the sum of exterior angles of a polygon is equal to 360 degrees, any polygon. Now, what we mean by exterior angles is if we continue this line right here, each of this line right here, each of the sides of the polygon, what we mean by exterior angles are these angles right here. This angle, this angle, this angle, this one, and this one. Now, the sum of all these exterior angles right here is equal to 360 degrees. Now, how does this help us with calculating this? We're told that each of the interior angles of the polygon is equal to 180 degrees. We know that the sum of angle on a straight line is equal to 180 degrees. So the total angle right here is equal to 180 degrees. And we're told that each of the angle of this polygon internal here is 140 degrees. That means each of the external angles is equal to 180 minus 140 degrees. So each external angle for this polygon is equal to 180 minus 140 degrees. which is equal to 40 degrees. So the sum of all the external angles is n multiplied by 40 degrees. And we know that this is equal to 360 degrees for all polygons. This is regardless of the number of sides. So n is equal to 360 divided by 40. And this is equal to 9. So the polygon has 9 sides. So if the polygon has 9 sides, then we can calculate the sum of angles of the interior angles. 140 multiplied by 9, and that's equal to 1260 degrees. So our answer right here is B. So question 47 says, a man bought a car newly for 1,250,000 naira. He had a crash with the car and later sold it at the rate of 1,085,000 naira. What is the percentage gain or loss of the man? So we know that profit or loss is equal to selling price minus the cost price. So the selling price is how much he sold the car for, and he sold it for 1,085,000. And cost price is how much he bought the car, and he bought it for 1,250,000. Now 1,085,000 minus 1,250,000 is minus 165,000 naira. So when our result is negative, that means he made a loss. Now to calculate the percentage loss, the percentage loss is equal to the loss over the cost price multiplied by 100. Now the loss is 165,000 and the cost price is 1,250,000 multiplied by 100. So if you evaluate this with your calculator, you have 13.2% loss. And the answer here is C. Question 48. If the volume of a frustum is given as this, find the VDR. So now we have V equals pi h over 3 into big R squared plus big R multiplied by small r plus r squared. And we're requested to find the VDR. So we're differentiating V with respect to capital R, not the small r, the capital R. So for example, anything that doesn't have the capital R, for us, that is a constant. So let's go. Our V, if we expand this bracket, becomes pi h over 3 r squared plus pi h over 3 r plus pi h over 3 small r squared. So now we can go ahead and find our dv d capital R. So here, if we have, remember that if we have x raised to power n, to differentiate this, we'll have nx n minus 1. So now we multiply this by 2, which gives us 2 over 3 pi h, and then our 2 here minus 1 gives us 1, so we're left with r. In this case, the power of our r is 1. So if you subtract 1 from this power, this becomes r raised to power 0, and anything raised to power 0 becomes 1. So here, our answer is going to be simply pi hr over 3, because we would have multiplied by 1 here, and r here becomes 1, so that's gone. Now in this case, this is a constant because we do not have a capital R here, and we know that when we differentiate a constant, that results in 0. So this cancels out. There's no result for this. So we're left with this for our dVdr. So we can go ahead and then factorize out pi h over 3 as well. And we're left with, if we cancel out pi h over 3 here, we have 2r and small r here. So our answer here is A. Now, we could have just gone ahead and differentiated what we have in this bracket as well, because this is a constant. And if you differentiate this, the constant is going to be left there at the end of our differentiation, and we'll just bring it back in as well. But just in case you've come across a question that has a capital R here, you have to differentiate because there's a capital R that needs to be differentiated here. But if you come across a question where the parameter outside of the bracket is a constant, you can just ignore that, differentiate the contents of your bracket, and then add up the constant afterwards. You'll get the same thing. Question 49 says express 0.0439 divided by 3.62 as a fraction. Now, if we have 0.0439 divided by 3.62, now if you evaluate this with your calculator, you would find that your answer is 0.01213. Now, obviously, if you look at our answers, you're only interested in our answer to two significant places. So we might as well say that this is approximately 0.012. Now, to convert this into fraction, well, we take our significant figures, which is 12, and then we look at how many places we need to move the decimal point to get to the back of 2 here. So that will be 1, 2, 3, and that will be divided by 1000. Now, if it were 2 places, that will be divided by 100. If it were, I don't know, 1 place, that will be divided by 10. But as it is, our fraction is 12 divided by 1000. So our answer here is C. Question 50. If 25 raised to the power 1 minus x multiplied by 5 raised to the power x plus 2 divided by 1 over 25 raised to the power x is equal to 625 raised to the power minus 1, find the value of x. So here we have 25 raised to the power 1 minus x multiplied by 5 raised to the power x plus 2 divided by 1 over 125 raised to the power x is equal to 625 raised to the power 1. So there are 3 laws of indices that we would need to remember to solve this problem. So the first one says that if a raised to the power m is multiplying a raised to the power n, then this is the same as a raised to the power m plus n. We would also have to remember that if a raised to the power m is dividing a raised to the power n, then this is the same as saying a raised to the power m minus n. And finally, we'll remember the one that says that if a raised to the power m is equal to a raised to the power n, then m has to be equal to n. So first, let's find a way of making all the bases here the same. So in this case, we'll have that 25 is equal to 5 squared. So that means that our new equation for this part is going to be 5 squared raised to the power 1 minus x. Now we'll leave this as it is, 5 raised to the power x plus 2. And we can also express 125 in terms of 5. And that will be 5 raised to the power 3. So this is going to be 1 divided by 5 raised to the power 3, all raised to the power x. We can also express 625 in terms of 5. And that's 5 raised to the power 4. Raised to the power minus 1. So now this is equal to 5 squared raised to the power 1 minus x multiplied by 5 raised to the power x plus 2 divided by, now 1 over 5 raised to the power 3 is the same as saying 5 raised to the power minus 3. So this is 5 raised to the power minus 3 multiplied by x equals 5 raised to the power 4 multiplied by minus 1. So now we can expand our brackets here. So this is the same as saying 2 multiplied by 2. 2 multiplied by 1 is equal to 5 raised to the power 2. And 2 multiplied by minus x is equal to minus 2x. So this is multiplied by 5 raised to the power x plus 2 divided by minus 3 multiplied by x is equal to 5 raised to the power minus 3x. And 4 multiplied by minus 1 is equal to 5 raised to the power minus 4. So now we can go ahead and apply our laws of indices. So first we have this multiplied by this. Now don't forget, if a raised to the power m multiplied by a raised to the power n, then we have that this is equal to a raised to the power n plus n. So then we can add up these indices right here. But there's also a division sign here. And we know that when the similar bases are divided, that is a subtraction. So then this is equal to 5 raised to power, we add up these two because of the multiplication sign, which is 2 minus 2x plus x plus 2. And we have to subtract this because of the division sign, minus 3x equals 5 raised to power minus 4. So now we have that if you have similar bases as we have here, 5 and 5, then the powers are equal. So we can get rid of the 5 altogether, and we can say that 2 minus 2x plus x plus 2. Now if we expand this, minus times minus is equal to plus, so we have plus 3x is equal to minus 4, which is the power we have here. So now we can collect like terms and then solve for x. So if we collect like terms here, we'll have that this is equal to minus 2x plus x plus 3x, which is what we have here, plus 2 plus 2 equals minus 4. So minus 2x plus x is equal to minus x. Minus x plus 3x is equal to 2x. 2 plus 2 is equal to plus 4. And that is equal to minus 4. So if we move 4 to this side and leave x here alone, we have minus 4. So this is 2x is equal to minus 4 minus 4, which is equal to minus 8. So if 2x is equal to minus 8, that means x is equal to minus 8 divided by 2, and that's equal to minus 4. So x is equal to minus 4. So the answer here is equal to A. Question 51 says a bricklayer charges 1,500 naira per day for himself and 500 naira per day for his assistants. If a 2-bedroom flat was built for 95,000 naira and the bricklayer worked 10 days more than his assistants, how much did the assistant receive? So if the bricklayer charges 1,500 for himself and he charges 500 for his assistant. Now if the assistant worked X number of days, now we're told that the bricklayer worked 10 more days, so the bricklayer would have worked for 10 plus X days. The total amount that was charged will be equal to 1,500 per day for the bricklayer times the number of days the bricklayer works, which is 10 plus X days, plus 500 per day for the assistant times the number of days the assistant works, which is X days, and the total amount that was charged was 95,000 naira. So now we have to solve for X to know how many number of days the assistant worked for. So in this case, we expand our brackets here. We have 1,500 multiplied by 10, that's 15,000, plus 1,500 multiplied by X is 1,500X, plus 500X equals 95,000. So now this is equal to 15,000 plus 1,500 plus 500X is 2,000X equals 95,000. So now we can make X the solid of the formula by transferring 15,000 to this side. So that will be equal to 2,000X equals 95,000, and this becomes minus 15,000. So this is 2,000X equals 80,000. Now X is equal to 80,000 divided by 2,000, which is equal to 40. So the assistant worked for 40 days. So now we're requested for, but what we're really asked to find is how much the assistant received. So to know how much the assistant received, he worked for 40 days and he was paid 500 per day. So 500 times 40 equals 20,000. So the assistant was paid 20,000 naira, and that's A. So question 52 says, find the equation of the locus of a point A with coordinates xy, which is equidistant from point B with coordinates 0, 2, and C with coordinates 2, 1. So imagine that we have a point A right here, and we've been told that the coordinates of this point A is x, y, and that this point is equidistant from a point B. So imagine that our B is here, and the coordinates of our B is 0, 2, 0, 2, and a point C with coordinates 2 and 1. So the distance between B and A is the same as the distance between A and C. Now the first thing we need to know is that if we have 2 points, to calculate the distance between those 2 points, the formula for that is the square root of x2 minus x1 squared plus y2 minus y1 squared. So now first, let's try to calculate the distance between points B and point A. So for that, this is going to be our x1, this is going to be our y1, and this is going to be our x2, and this is going to be our y2. So the distance between points B and A is the square root of our x2 is x minus our x1, which is 0, all squared, plus our y2, which is y, minus our y1, which is 2, all squared. Now we've been told that this distance is the same as this distance. So the distance between points B and A is the same as the distance between point A and C. So this is going to be equal to the distance between point A and C. Now to calculate the distance between point A and C, we have to relabel our points. So now this is going to be our new x1, this is going to be our y1, and this is going to be our x2 and our y2. So now the distance between point A and C is the square root of x2, in this case is 2 minus x1, which is x squared, plus y2 is 1 minus our y1, which is y squared. So now we can go ahead and evaluate this and solve for xy. So first things we need to do is this square root here will cancel out the square root here. So our equation then becomes, we can go ahead and expand what we have in here. If we have x minus 0 squared, let's just evaluate that on the side here, and then we can insert that into our equation. So x minus 0 squared, to avoid any confusion, x multiplied by x is going to be x squared. X multiplied by minus 0 is 0. 0 multiplied by x is 0 as well, and 0 multiplied by 0 is 0. So we're left with x squared here. So x minus 0 squared becomes x squared. So what about y minus 2 squared? Now y minus 2 squared is y minus 2 multiplied by y minus 2. So y multiplied by y equals y squared. Y multiplied by minus 2 equals minus 2y. Minus 2 multiplied by y equals minus 2y. And minus 2 multiplied by minus 2 equals plus 4. So our equation is y squared. Minus 2y minus 2y is minus 4y plus 4. So y minus 2 squared becomes plus y squared minus 4y plus 4. So if you evaluate these in the same way, you find out that 2 minus x squared results in x squared minus 4x plus 4, and 1 minus y squared results in y squared minus 2y plus 1. So all we've done here is the square root here cancels out the square root here, and then we expanded our brackets so we can solve for our x and our y's. So let's collect like terms now. So let's start with our x squared. So we have our x squared here. Now we have another x squared here. So if we move our x squared over to this side, this is going to be minus x squared. Then we collect our x's. So we have only one x variable here, and that's minus 4x. So if we move minus 4x to this side, we have plus 4x. Then let's collect our y squared. So plus y squared, which we have on this side. But we have another y squared here. So if we move our y squared over to this side, it becomes minus y squared. So now let's collect our y's. So we have a minus 4y here. So that's going to be minus 4y. and we have a minus 2y here. So if we move minus 2y to this side, it becomes plus 2y. And then our constants will be on the right side of our equation. So if we move our constant, we have plus 4 here, so 4. We have 1 here, that's plus 1. And we have a plus 4 here. But if we move the plus 4 over to this side, it's going to become minus 4. So now that we have collected like terms, we can go ahead and solve. So x squared minus x squared cancels out each other here. We have our 4x. Y squared minus y squared cancels out each other here. And minus 4y plus 2y results in minus 2y. And 4 plus 1 is 5, and 5 minus 4 equals 1. So the equation for the locus of the point ax squared is 4x minus 2y equals 1. And the answer corresponding to that here is C. Question 53 says, a factory worker earns 50,000 naira per month, out of which he spends 15% on his children's education, 13,600 naira on food, 3% on electricity, and uses the rest for his personal purpose. How much does he have left? So the total earnings is equal to 50,000 naira. Now we're told that he spends 15% on his children's education. So for education, he spends 15%. So 15% of his entire salary is 15%, 15 over 100 times 50,000. And this will result in 15 times 500 is 7,500. So he spends 7,500 on education. And then we were told that on food, he spends 13,600. So 13,600 on food. By the way, all these are expenses. This is what he earns, but all these are expenses, so they are negative. And then he spends on electricity. He spends 3% on electricity. So 3% of his entire pay is 3 over 100 times 50,000. And that will result in 3 times 500 is equal to 1,500. So on electricity, he spends 1,500. So 50,000 minus all of his expenses, which is 7,500 on education, 13,600 on food, and 1,500 on electricity, results in 27,400. So he's left with 27,400, which is C. 54 says a binary operation represented by this triangle is defined by A operation B equals A plus 3B plus 2. Now find 3 operation 2 in brackets operation 5. So let's start by handling this bracket. So now we know that 3 operation 2 is equal to, so A is 3 plus 3 multiplied by B, which is 2, plus 2. So this is equal to 3 plus 6 plus 2. And this is equal to 11. So now we have this is 11 operation 5. And that's going to be equal to A, which is 11, plus 3B, which is 5, plus 2. So this is 11 plus 3 times 5 is 15, plus 2. So 11, that's equal to 11 plus 15 is 26. 26 plus 2 is 28. So that's equal to C. Question 55 says, if m varies directly as n and inversely as the root of p, given that m is equal to 3 and n is equal to 5, and p is equal to 25, find the value of p when m equals 2 and n equals 6. So we're told that m varies directly as n and inversely as the square root of p. So now we know that when we have a variation sign, this is the same as saying equals to a constant of proportionality. So we can rewrite this as m equals kn over the square root of p. So we're given a first initial set of values, which are what we have here. And then through that, we can look for our k. So if we substitute these values into this equation, we have that m is equal to 3, which is equal to, we don't know our k, that's what we're still looking for. N is equal to 5. And we have that p is equal to 25. So the square root of 25. So this is equal to 3 equals k5 over the square root of 25 is equal to 5. So if this cancels out this, we know that our k is equal to 3. So if k is equal to 3, then we can rewrite this equation right here as m is equal to 3n over the square root of p. Now that we know our k equals 3. So from this, we will use the new set of values that we're given, which is m equals 2 and n equals 6, and we're required to find p. So here, so if we put those into our equation here, we'll have m equals to 2 equals 3, n equals 6 over the square root of p. So to make p the square root of formula here, we just need to cross multiply, send p over to this side and bring 2 down here. So we'll have that the square root of p is equal to 3 multiplied by 6 is 18, divided by 2 comes down here, 2. So the square root of p equals 9. So if the square root of p equals 9, if we square both sides, we have that p is equal to 81. So our answer here is D. Question 56 says, the table below gives the scores of a group of students in a further mathematics test. Find the mode of the distribution. Now the mode is simply the score with the highest frequency, and that's simply 5. Now the mode is not the frequency itself, but the score with the highest frequency, and 5 is the score with the highest frequency. So our answer here is C. Question 57 says, this table below gives the scores of a group of students in a further mathematics test. Calculate the mean deviation for the distribution. So the formula for the mean deviation is equal to the summation of the frequency multiplied by the modulus of xi minus x bar divided by the summation of the frequency. So the first thing we need to do is to calculate our mean, which is our s bar. Now the formula for a mean, as we know, is the summation of fx divided by the summation of f. So the fx is simply the multiplication of each score by its frequency, and then we add them all up and divided by the summation of the frequency. So fx for here is 1 times 4 equals 4, 2 times 6 is equal to 12, 3 times 8 is 24, 4 times 4 equals 16, 5 times 10 equals 50, and 6 times 6 equals 36, and 7 times 4 equals 14. Now if we add all these up, we would have 156. And if we add up all the frequencies, just 4 plus 6 plus 8 and all that, we'll have that the summation of our frequency equals 40. So 156 divided by 40 is equal to 3.9. So our mean is equal to 3.1. So let's just write that down here. Our mean equals 3.9. And let's get rid of all this. Now to calculate the mean deviation, I think we should just go ahead and form a table to avoid confusion. And the table looks like this. Now all this table is our x's are what we have highlighted here. Those are our scores, 1, 2 to 7. And these are our frequencies. Now x minus x bar means each score minus the mean. So for example, this score here is 1. 1 minus the mean 3.9 equals minus 2.9. 2 minus 3.9 equals minus 1.9. 3 minus 3.9 equals minus 0.9, and so on. So this here is simply the modulus of the preceding column here. So whatever number we have here, we ignore this negative sign and just take the value, the absolute value of that number. So minus 2.9 becomes 2.9, minus 1.9 becomes 1.9, and so on. Now, here is simply the preceding column multiplied by the frequency. So 2.9 multiplied by 4 gives us 11.6. 1.9 multiplied by 6 gives us 11.4, and so on. Now, what we have to do now is to add up all our numbers here. And if we add up all these figures here, we're going to have 60.4. So all of this equals 60.4. Now, you would see that this is the numerator of our formula here is the summation of all this, which is what we just got, 60.4. So if I move this down here, so the numerator here is the summation of all this. This is equal to 60.4. And we've already gotten the summation of our frequency before when we calculated our mean, and that's 40. So 60.4 divided by 40 is equal to 1.51. So our mean deviation is 1.51, and that's equal to C here. Question 58 says integrate 4x raised to the power minus 3 minus 7x squared plus 5x minus 6 with respect to x. So we have 4x minus 3 minus 7x squared plus 5x minus 6. So we're integrating this with respect to x. So first, let's remind ourselves that to integrate x raised to the power n, what we have is we take our power and we add 1 to our power. So this becomes x raised to the power n plus 1. And then we divide everything by n plus 1. So let's go. So to integrate 4x raised to the power minus 3, this is going to become 4x minus 3 plus 1, all divided by minus 3 plus 1. Then minus 7x raised to the power 2 plus 1 divided by 2 plus 1 plus 5x. Now our power here is 1 already, so that will be 1 plus 1 all divided by 1 plus 1. And for 6x, now what this literally means is 6x raised to the power 0, because anything raised to the power 0 is equal to 1. So the power of our x here is literally 0. And if we do that, that's going to be 0 plus 1 divided by 1. So now this is going to be 6x raised to the power 1, and that's going to be 6x. So what this means is that whenever you're integrating a constant with respect to x, all you have to do is add x to that constant, and 6 becomes 6x. So now this is going to be 4x minus 3 plus 1 becomes raised to the power minus 2 divided by minus 2. 2 plus 1 becomes 3, so this is going to be minus 7x cubed divided by 3. And this is going to be 5x squared divided by 2 minus 6x. So 4 can cancel out minus 2 here to give us minus 2x raised to the power minus 2 minus 7x cubed raised to the power divided by 3 plus 5 over 2x squared minus 6x. So this is our final answer for this problem. And the solution that corresponds to that is our option A. Question 59 says, find the probability that a number selected at random from 21 to 34 is a multiple of 3. Now the probability is equal to the number of observations divided by total outcome. So first, let's write out the number from 21 to 34. So in total, from 21 to 34, we have 14 numbers. So here, the total outcome is equal to 14. Now we need to find the number of the observations. And here, what we're observing are the multiples of 3. So how many multiples of 3 do we have here? We have 21 as a multiple of 3. We have 24 as a multiple of 3. We have 27 as a multiple of 3. We have 30 as a multiple of 3. And we have 33 as a multiple of 3. So how many observations do we have? We have 1, 2, 3, 4, 5. So here, the number of the observation 5. So our probability is 5 over 14. And the answer here is C. So question 60 says, if the third and the seventh term of a geometric projection are 9 and 1 over 9 respectively. Find the common ratio. So we know that for geometric projections, our nth term Tn is equal to AR raised to power n minus 1. So our R here is the common ratio we've been requested to find. So we know that when n is 3, for our third term, n is equal to 3. And that means T3 is equal to AR. Now n is 3 here, so 3 minus 1 is equal to 2. And we're told that this is equal to 9 from our question. And for our seventh term, n is equal to 7. So here T7 is equal to AR. Now n is equal to 7 here, so 7 minus 1 is equal to AR raised to power 6. And this is 1 over 9. So if we have T7 divided by T3, this is equal to AR6, AR raised to power 6 divided by AR raised to power 2. And this is equal to 1 over 9 divided by 9. So A here cancels out the A here. And when we have R raised to power 6 divided by R raised to power 2, that would result in, this will cancel out this to leave us with R raised to power 4 here. Now 1 over 9 divided by 9, that's 1 over 9 divided by 9. If we change this to a multiplication sign and flip this, this will be the same as 1 over 9 multiplied by 1 over 9. And this is equal to 1 over 9 times 9 is 81. So this is the same as saying R raised to power 4 is equal to 1 over 81. So to make R the solution of the formula here, all we have to do is find the fourth root of both sides of this equation. So if we do that, this will cancel out the power of 4 here to leave us with R here. And the fourth root of 1 is still 1. And the fourth root of 81 is equal to 3. So R, which is our common ratio, is equal to 1 over 3. So our answer here is A. 61 says if the universal set U is equal to X such that 1 is less than or equal to X and X is less than or equal to 20. And A is equal to Y such that this is the multiple of 3 and B such that Z are odd numbers, find A intersection B. So the universal sets are numbers from 1 to 20, including them because we know that we're told that this is 1 is less than and equal to X, and X is also less than and equal to 20. So that's from 1 to 20. Now the multiples of 3 in the universal set from 1 to 20 is equal to 3, 6, 9, 12, 15, and 18. Now the odd numbers from 1 to 20 are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So we're told to find A intersection B. So A intersection B means what are the numbers that are similar to both sets here? So what numbers are similar to both sets here? We have 3 is similar to both sets here. We also have that 9 is similar to both sets here. And we have 15. So our answer is 3, 9, 15. And the corresponding value here is, the corresponding option here is C, 3, 9, and 15. Question 62 says, in a committee of 5, which must be selected from 4 males and 3 females, in how many ways can the members be chosen if it were to include 2 females? So whenever you see a question that says, how many ways can we select? So selection is a combination problem. And by combination, we know that what we mean is n combination r. And this is the same as n factorial divided by n minus r factorial multiplied by r factorial. But if we had seen an arrangement problem, so how many ways can this be arranged? Or if the question says how many ways can this be arranged, That would have been a permutation question. And a permutation is n permutation r. And that is n factorial divided by n minus r factorial. So when the question says how many ways can be select from a certain amount of something, we are dealing with a combination problem. But if we were asked how many ways it can be arranged, that would be a permutation problem. So let's go to the question. So the total number of males we have to select from are 4 males. We're told that we have 4 males and we have 3 females. So these are the total number of people that are available for selection. So the total number of people that are available for selection is our n. Now we're told that to make up the members of committee of 5, we have to include 2 females. So to include 2 females, we'll have 2 females, and then that will mean that we would have 3 males. So the number of committee that we eventually select are r, but we can select different combination of these three males and 2 females from the available people to be selected. So how do we do that? So now we have to calculate the number of ways that 3 males can be selected from the available 4. That is n combination r, and our n in this case is 4 combination r, which is our 3 males that are selected eventually, and the number of ways that 2 females can be selected from the available 3 females. So n in this case is 3, and our r in this case is the 2 females that are eventually selected. So we'll have to solve this differently. So for this case, we have 4 factorial divided by 4 minus 3 factorial multiplied by 3 factorial. Don't forget, this is a combination. Multiplied by n factorial, which is 3 factorial, divided by n minus r factorial is 3 minus 2 factorial, multiplied by r factorial, which is 2 factorial. So in this case, 4 factorial is simply 4 times 3 times 2 times 1, divided by 4 minus 1 factorial is 1, multiplied by 3 factorial, that's 3 times 2. So we multiply this by 3 factorial is 3 times 2 times 1, divided by 3 minus 2 factorial, that's 1, multiplied by 2 factorial is simply 2 times 1. So 3 can cancel out 3 here, 2 can cancel out 2 here. We're left with 4 on this side, and 2 cancels out 2 here. We're left with 3 on this side. So 4 times 3 is equal to 12. So 12 ways can we select 3 males and 2 females from a total population of 4 males and 3 females. So our answer here is D. So question 63 says, find the value of k in the equation the square root of 28 plus the square root of 112 minus the square root of k equals the square root of 175. So the best way of solving this problem is to break down these radical numbers such that we know that the square root of 28 is the same as the square root of 4 multiplied by 7. 4 multiplied by 7 is equal to 28, plus the square root of 112 is the same as the square root of 16 times 7 minus the square root of k, and we know that the square root of 175 is the same as the square root of 25 times 7. Now 4 is a perfect square, so if we bring it out of this square root sign, we'll have that the square root of 4 is equal to 2. So this becomes 2 root 7 plus 16 is also a perfect square. If we bring 16 out of this square root sign, that's the square root of 16 is 4. So this becomes 4 root 7 minus root k equals 25 is a perfect square as well. So if we bring it out of the square root sign, the square root of 25 is 5. So that's 5 root 7. So now we can collect like terms and then solve for k. So if we bring 5 root 7 to this side of our equation, this will become minus 5 root 7. So we can rewrite this as 2 root 7 plus 4 root 7. Bringing this will become minus 5 root 7. And then we can bring minus k, and we can bring the root of k to this side, and it becomes from minus k becomes plus root k. So we've made root k the solid of our formula. So if we combine all this, when you combine surds such as this, you can simply combine the outer numbers here. So 2 plus 4 is 6, and 6 minus 5 is equal to 1. So this is the same as saying root 7 is equal to root k. So if we find the square root of both sides, or if we find the square of both sides rather, the square root cancels out the square root here, and we have that k is equal to 7. So our answer here is B. 64 says we should evaluate this expression here. So the expression we have is that 2 log to base 3 of 9 multiplied by log to the base 3 of 81 raised to power minus 2 divided by log to the base 5 of 625. So the first thing we should attempt to do is simplify these huge numbers here. So if we do that, we'll have that this is equal to 2 log to the base 3. We know that 9 is the same as 3 raised to power 2 multiplied by log to the base 3. And 81 is the same as 3 raised to power 4, all raised to power minus 2. And we know that log to the base 5, 625 is the same as 5 raised to power 4. So now we can rewrite our equation as 2 log to the base 3 of 3 squared multiplied by log to the base 3. Now 4 multiplied by minus 2 is equal to minus 8. So this becomes 3 raised to power minus 8, all divided by log to the base 5 of 5 raised to power 4. So we need to know some laws of logarithm for us to continue solving this. Now the first one we need to know says that if we have log to the base a of x raised to power n, now this is the same as bringing this power n to the front of our logarithm here, and this is the same as n log to the base a of x. So if we use that on this equation that we have here, we can then say that if we apply that to this power here, we can bring 2 to this front here, and 2 multiplied by 2 here will become 4. 4 log to the base 3 of 3 multiplied by, if we bring minus 8 to the front here, we'll have minus 8 log to the base 3 of 3 divided by, and if we bring 4 to the front here, we have that 4 log to the base 5 of 5. Now the next law of logarithm we need to know is that when we have log to the base a of a, when the base and the number whose logarithm we're finding are the same, this is the same as 1. So log to the base a of a is equal to 1. So if we apply that here, we'll have that log to the base 3 of 3. This simplifies to 1. Log to the base 3 of 3 is also 1. And log to the base 5 of 5 is also 1. So our equation, what is left of our equation is 4 multiplied by minus 8, all divided by 4. So 4 can cancel out 4 here, and we're left with minus 8. So our answer here is C. Question 65 says, find the value of x in this inequality here. So to solve this, first let's resolve everything here under one denominator, and then we'll get rid of the denominators. To do that, if we take a common denominator of 3 here, so 3 divided by 3 equals 1. 1 times this results in 2 plus 2x. And if we assume a denominator of 1 here, 3 divided by 1 is 3. 3 times minus 2 is equal to minus 6. And so this is greater than or equal to 4x minus 6 over 5. So to get rid of the denominator, all we have to do is cross multiply. So now this will be 5 multiplied by 2 plus 2x minus 6 is greater than or equal to 3 multiplied by 4x minus 6. So this is 5 multiplied by 2 equals 10. 5 multiplied by 2x is plus 10x. And 5 multiplied by minus 6 is minus 30. So this is greater than 3 or greater than or equal to 3 multiplied by 4x is equal to 12x, and 3 multiplied by minus 6 is minus 18. So now we can go ahead and collect like terms. So if we send all the x's to the left side, we'll have, in this case, this is 10x. If we bring this over here, and that will be minus 12x. And on the right side, we have minus 18, which is what we have here. And then we bring 10 to this side, that will be minus 10 when it crosses over. And this will be from minus 30 becomes plus 30 when it crosses over. So 10x minus 12x will result in minus 2x. And this is greater than or equal to minus 18 minus 10 is minus 28. Plus 30, that's equal to 2. So now we have to divide both sides by minus 2 to make x a certain formula. So if we do that, this divided by minus 2 and this divided by minus 2. So minus 2 cancels out minus 2 here to give us x. But because we've divided both sides by a negative number here, our inequality sign has to change. So it's going to change from greater than or equal to less than or equal to. And 2 divided by minus 2 results in minus 1. So our answer is x is less than or equal to minus 1. And the answer here is C. Question 66 says, determine the values for which x squared minus 7x plus 10 is less than or equal to 0. So when we have a situation like this, the first thing we need to is ignore the inequality sign and solve the quadratic equation. So if we do that, we'll have that x squared minus 7x plus 10 is equal to 0. First, we have to find the factors of 10. So the factors of 10 are 1, 2, 5, and 10. So what's two factors here, which if we combine would result in minus 7? So we have minus 2 minus 5. Minus 2 minus 5 is the same as minus 7. So now we have to replace minus 7 here by minus 2 minus 5. So our equation becomes x squared minus 2x minus 5x plus 10 equals 0. So now let's factorize out this expression. So we start with the first two, x squared minus 2x. Now x is common to both terms here. So x squared divided by x is equal to x, and minus 2x divided by x is equal to minus 2. So minus 5x plus 10. Now minus 5 is common to both terms here. So minus 5x divided by minus 5 is equal to x, and 10 divided by minus 5 is equal to minus 2 equals 0. So now we have to factorize the entire expression, and x minus 2 is common to both sides here. So we write that down. And then now we can write down the external entities here, which is x minus 5 equals 2. So if we have two items multiplying each other and the result is equal to 0, that means one of them is equal to 0, because anything multiplied by 0 is equal to 0. So either x minus 2 is equal to 0 or x minus 5 is equal to 0. So from here, you can tell that x is equal to 2 or x is equal to 5. Now, if what we were requested is to solve this quadratic equation, this would have been our answers. But what we want to know is what values of x, which when we plug into this equation gives us a solution that is less than or equal to 0. Now, to do that, we would have to draw a number line. And on this number line, we are going to mark the two solutions we got to our quadratic equation. Here, in this case, is 2 and 5. So we're going to test out 3 regions. The first region is the region when x is less than 2. The second region is the region when x is between 2 and 5. And the third region is the region when x is greater than 5. So let's start. Now, if we test out when x is less than 2, so let's try any number when that is less than 2. So let's try 1, for example. So we put 1 into this our equation here. So that's going to be 1 squared. So x squared becomes 1 squared minus 7 multiplied by 1 plus 10. Now 1 squared is 1. 7 multiplied by 1 becomes 7 plus 10. So 1 minus 7 is equal to minus 6, and minus 6 plus 10 is equal to 4. So 4 is not less than or equal to 0. So in this case, this region does not work for us. Now we try the second region, which is when x is between 2 and 5. So that means that 2 is less than x, or x is less than 5. So let's try, in this case, let's try 3. Now 3 is between 2 and 5. So our equation becomes 3 squared minus 7 multiplied by 3 plus 10. So 3 squared is equal to 9 minus 7 times 3 equals 21 plus 10. So 9 minus 21 is equal to minus 12 plus 10. And this is equal to minus 2. So obviously, minus 2 is less than or equal to 0. So this region satisfies the equation we have here. So this is a good region for us. Now let's try the third one. The third region says that when x is greater than 5. So let's try 7. So the equation becomes 7 squared minus 7 multiplied by 7 plus 10. So 7 squared is 49. 7 multiplied by 7 is also 49 plus 10. So 49 minus 49 cancels out, and we are left with 10. Obviously, 10 is not less than or equal to 0. So this area, it's as well does not satisfy the area that satisfies this inequality is when 2 is less than x and x is less than 5. But we also know from here that x is equal to 2 and x is equal to 5. So to complete it, our real solution is going to be that 2 is less than but also equal to x, and x is less than but also equal to 5. And that's our final answer. That is the region of values that satisfy this inequality here. So our final answer here is going to be D. Question 67 says, find the polynomial if given qx is equal to x squared minus x minus 5, and dx is equal to 3x minus 1, and rx is equal to 7. That qx is the quotient, dx is the divisor, and rx is the remainder. So we're requested to find a polynomial which, when we divide by the divisor 3x minus 1, results into the quotient x squared minus x minus 5 and gives us a remainder of 7. If we have a number x, for example, and we divide this by a divisor d, this is going to result into a quotient q. Now, to find, if we have the quotient and the divisor, to find the number x, which is the polynomial we're trying to look for here, all we have to do is multiply q by d. But what if there was a remainder? Now, the remainder, to get this number, all we have to do is add the remainder to this. So in other words, this is exactly how we'll solve this as well. If we assume that the polynomial we're looking for is x, now our q is the quotient in this case, that is x squared minus x minus 5. Our d is the divisor 3x minus 1, and all this with a remainder of 7. So x is equal to, if we expand this, we have that x squared multiplied by 3x is equal to 3x cubed, and x squared multiplied by minus 1 is equal to minus x squared. Now minus x multiplied by 3x is minus 3x squared, and minus x multiplied by minus 1 is equal to plus x. Minus 5 multiplied by 3x is minus 15x, and minus 5 multiplied by minus 1 is equal to plus 5. Now if we add our plus 7, so now we can evaluate this polynomial. X is equal to 3x cubed stands alone, so that's 3x cubed. Now minus x squared minus 3x squared results in minus 4x squared, and x minus 15x results in minus 14x, and 5 plus 7 results in 12. So 3x cubed, so our polynomial, our original polynomial here is 3x cubed minus 4x squared minus 14x plus 12, and that is A. And you can try it out. If you divide this by the divisor here, you're going to have this result and a remainder of 7. So our answer is A. Question 68 says if 2x squared plus x minus 3 divides x minus 2, find the remainder. So the remainder theorem says that if we have a polynomial p of x and this is divided by x minus a, then our remainder is p of a. So in this case, our p of x is the polynomial which we're dividing, which is 2x squared plus x minus 3. And our x of x minus a in this case is x minus 2. So we can say that our a is equal to 2 from here. Now that was given in the question. Now to find the remainder, which is p of a, all we have to do is substitute x in this our polynomial by our a, which is 2. So our remainder is going to be p of a, which is p of 2. So p of 2 is going to be 2x here, that's 2 squared plus 2 minus 3. So 2 squared is 4. 4 times 2 is equal to 8 plus 2 minus 3. So 8 plus 2 is 10. 10 minus 3 equals 7. So our remainder is 7, which is A. Question 69 says, if the determinant of the 3 by 3 matrix we have here is equal to 132, find the value of x. Now to find the determinant of a 3 by 3 matrix, the first thing we do is we assign signs to each column. So we start with plus here, minus here, and then plus here. Then the next thing we do is to take the first element of our matrix here, which is 2. So this is going to be plus 2. So this is plus 2. And then we cancel out the first column here as well as the first row here. So now we're left with 4 items here. And now we write out those 4 items 1, 4, 3, 2. Then the next thing we do is we take the second element here, which is minus 5. So in this case, this is going to be minus, which is the minus we have here, then minus 5, the item itself, the element itself, which is minus 5. And then we do the same thing by crossing out the column containing the second element here and the row as well. So we're left with 4 terms now, just like we did before. And so we write down those 4 terms as well, which is going to be x, 4, 0, and 2. And then we do the same thing to the third term here, which is 3. So this is going to be plus, which is the plus we have here, 3. We also cancel out the row containing the 3 as well as the column containing the 3. And so we're left with these 4 items here. So we can write down the remaining 4 items as x, 1, 0, and 3. So we have that all this is equal to 132. So now we can go ahead and evaluate our determinant. Now to do that, we cross multiply what we have in the square brackets here and subtract the results from each other. So what I mean by that is we have 2 here, and then 1 times 2 is equal to 2, minus 3 times 4, that's equal to 12. We have minus 5. X times 2 is equal to 2x, minus 0 times 4, which is equal to 0, plus 3. X times 3 equals 3x, and we have 0 times 1 is equal to 0, so minus 0. All this equals 132. So now we have 2 minus 12 equals minus 10, minus times minus is equal to plus, so we can simply put this as plus 5. 2x minus 0 equals 2x, and 3 multiplied by 3x minus 0 equals 3x. All this equals 132. So now we can evaluate this as 2 times minus 10 equals minus 20. 5 times 2x equals plus 10x. And 3 times 3x equals plus 9x equals 132. So this is the same as minus 20, 10x plus 9x equals plus 19x equals 132. So if we make x equal formula here and we move the 20 to the side, we'll have that 19x is equal to 132 plus 20, which is equal to 152. So if 19x is equal to 152, then x equals 152 over 19, and x is equal to 8. So our answer here is B. Question 70 says, given the matrix A equals this, find the inverse of matrix A. So if we have a matrix A equals A, B, C, D. Now the inverse of this matrix A inverse is equal to 1 over the determinant of A. So now we have to flip the elements on this diagonal here. So this is going to become D, A, and we keep the elements on the diagonal here, B, C. However, we have to multiply them by minus 1. So B becomes minus B, and C becomes minus C. And here is how we evaluate the inverse of a matrix. So if we apply that to this case as well. So first thing is we find the determinant of this matrix. So the determinant of the matrix A is equal to, we multiply the diagonal here, which is 3 multiplied by 6, minus 1 multiplied by minus 2. So this is going to be 3 times 6 is 18, minus 1 times minus 2 equals minus 2. So this is going to be 18 plus 2, which equals 20. So the determinant of A is 20. So now the inverse of A equals 1 over the determinant of A, which is 20, multiplied by, so we flip the elements of this diagonal here. So this is going to be 6 and 3 here. And then we multiply this by minus 1. So minus 1 times minus 2 equals 2. And minus 1 times 1 equals minus 1. So we're almost there. So finally, the inverse of the matrix A is, so we're going to multiply each of our element of our matrix here by 1 over 20. So if we do that, 6 times 1 over 20 becomes 6 over 20. 2 times 1 over 20 becomes 2 over 20. This becomes minus 1 over 20. And this becomes 3 over 20. So if we reduce each of these fractions, 2 can go here 3 times and 2 can go here 10 times. So this is 3 over 10. 2 over 20 becomes 1 over 10. Minus 1 over 20 remains the same. And 3 over 20 remains the same. So the option corresponding to that is D. Question 71 says, if y equals 8x cubed minus 3x squared plus 7x minus 1, find the square y over the x squared. So all we are requested to do is to differentiate this twice. So if we have y equals 8x cubed minus 3x squared plus 7x minus 1. So don't forget that if we have x raised to power n, the differential of x raised to power n is we bring our power down here to multiply x, which is going to be n multiplied by x, and then we subtract 1 from the power here, which is n minus 1. So the first differential of our expression here is we bring 3 down to multiply 8 here. This is going to be 24x, and 3 minus 1 equals 2. So if we do that the same here, 2 multiplied by 3 becomes 6. And 2 minus 1 is 1. So we leave it as 6x. And for 7x, our power here is 1. So 1 multiplied by 7 remains 7. But 1 minus 1 becomes 0. And anything raised to power 0 is 1. So the x disappears here. So when we have an expression 7x, if we differentiate 7x, we're left with 7. And if we differentiate a constant, we have 0. So nothing comes here. Now for the second differential, which is this, 2 multiplied by 24 becomes 48x, and 2 minus 1 is 1, so we have 48x. And like I said before, when we have 6x and we differentiate this, we're left with just 6. And if we differentiate it constant, that leaves us with 0. So our final answer is 48x minus 6, and that is A. Question 72 says differentiate 2x over sine x with respect to x. So in this case, we're going to use the quotient rule. So the quotient rule says if we have u over v, and we want to find the differential of this with respect to x. Now this is equal to v, we multiply that by the differential of u, which is the u dx, minus u, we multiply that by the differential of v, which is the v dx, all divided by v squared. So in this case, we have that 2x divided by sine x. So 2x is equal to our u, and sine x is equal to our v. So if we have that u equals 2x, then the u dx is equal to, the differential of 2x is simply 2. And if we have that our v equals sine x, then dv dx, the differential of sine x is simply cos x. So now we can go ahead and solve our differential here. So v equals sine x multiplied by du dx, which is 2, multiplied by 2, minus u, which is 2x, multiplied by dv dx. Our dv dx is cos x, all divided by v squared. V squared is sine square x. So now that we have this, if we expand our brackets here, we have that 2 multiplied by sine x is equal to 2 sine x minus 2x multiplied by cos x is simply 2x cos x, all divided by sine square x. So now if we factorize 2 sine x from the numerator here, we have that 2 sine x is common to both sides. So 2 sine x divided by 2 sine x is equal to 1 minus. Now let's go, there's a sidebar here. If we have 2x cos x divided by 2 sine x, so that's 2x cos x here, and we divide it by the common factor 2 sine x. So 2 cancels out 2 here. Now if we have that sine x over cos x, now we know that this is equal to tan x. But what if we have the inverse of this, which is cos x over sine x, like what we have here, cos x over sine x. Now this is the same as 1 over tan x. And 1 over tan x, the inverse of tan x is the same as cotangent x, which is cot x. So what we have here is simply, we have this x, and then cos x over sine x is equal to cot x. So this is going to be equal to 1 minus x cot x, all divided by sine square x. So from here, sine x can cancel out. We have sine x times sine x here. So can cancel out one of the sine x's here. So we have 2 multiplied by 1 minus x cot x divided by sine x. Now if we look at our options here, none of these options correspond with what we have here. So we have to find a way to further simplify. And the answer to that is in the denominator here, sine x. Now we know that if we have another sidebar here, if we have 1 over sine x, this is the same as cosec x. So now this is 1 over sine x here will become cosec x. So our new equation is going to be 2 cosec x into 1 minus x cot x. And the answer here is, question 73 says find the distance between the points C and D with these coordinates. Now To find the distance between two coordinates d, this is the same. The formula for this is the square root of x2 minus x1 squared plus y2 minus y1 squared. So in this case, this is our x1, this is our y1, and this is our x2, this is our y2. So if we solve for this, d is going to be equal to square root of x2 is 5 minus x1, which is 2, all squared, plus y2 is 6 minus y1, which is 2, all squared. So d equals 5 minus 2 is 3 squared, plus 6 minus 2 is 4 squared, square root. So this is the square root of 9 plus 16, which is the square root of 25. So the distance is equal to 5 units. So the answer here is D. Question 75 says the table above is the distribution of data with mean equals to 3. Find the value of y. So we know that the mean of a data presented such as this is the same as the summation of the frequency multiplied by each mark divided by the summation of the frequency. And this, we're told, is equal to 3. So summation of frequency multiplied by x is going to be equal to 1. In this case, 1 multiplied by 2y minus 2 equals 2y minus 2 plus 2 multiplied by y minus 1 plus 3 multiplied by 3y minus 4 plus 4 multiplied by 3 minus y plus 5 multiplied by 6 minus 2y. So this is equal to 2y minus 2 plus 2 times y equals 2y, and 2 multiplied by minus 1 equals minus 2, plus this becomes 9y minus 3 times minus 4 equals minus 12, plus 4 times 3 becomes 12, minus 4 times minus y becomes minus 4y, plus 5 times 6 equals 30, and 5 times minus 2y equals minus 10y. So now if we collect like terms together, we have 2y plus 2y plus 9y minus 4y minus 10y. Minus 2 minus 2 minus 12 plus 12 plus 30. So 2y plus 2y equals 4y. 4y plus 9y equals 13y. 13y minus 4y equals 9y. And 9y minus 10y equals minus y. Now minus 2 minus 2 equals minus 4. Minus 4 minus 12 is minus 16. Minus 16 plus 12 is minus 4. And minus 4 plus 30 equals plus 26. So this is the summation of f multiplied by x. Now the summation of our frequencies equals 2y minus 2 plus y minus 1 plus 3y minus 4 plus 3 minus y plus 6 minus 2y. This is simply the summation of all the frequencies here. And if we evaluate that like we've done before, we'll get 3y plus 2. So now our mean is equal to summation of f of x here, which is minus y plus 26 divided by 3y plus 2. And this is equal to 3, mean of 3, as we have been told. So if we cross multiply, we'll have that minus y plus 26 is equal to 3 multiplied by 3y plus 2. And this is minus y plus 26 is equal to 3 times 3y equals 9y plus 3 times 2 equals 6. So if we collect like terms here, and we have 6 sent to this side, so this is going to be equal to 26 minus 6, this becomes minus 6, and 9y, if we send our minus y to this side, it's become plus y. So 26 minus 6 becomes 20, and 9y plus y becomes 10y. So if 20 equals 10y, if we divide both sides by 10, we have that our y is equal to 2. So in this case, y equals 2, the answer here is B. Question 76 says, the histogram above represents the number of candidates who did further mathematics examinations in the school. How many candidates scored more than 40? So the cutoff mark here is 40. So we want to evaluate the number of students that got more than 40, which is what we have here. So those that got 50 marks, from here we can see that that's 55. Those that got 60 marks, from here we can see that's 45 plus 45. Those that got 70 marks, from here we can see that that is 30 plus 30. Those that got 80 marks, from here we can see that that is 15. So that's 15 students got 50 marks. And those that got 90 marks, clearly there are 5 of them, so 5. So 55 plus 45 plus 30 plus 15 plus 5 would equal 150. So 150 students got more than 40 marks. So that's C. Question 77 says, in the circle above with center O and radius 7 centimeters, find the length of the arc AB when angle AOB is equal to 57 degrees. So what we're looking for is the length of this arc right here, arc AB. So how do we do this? First, we can find the circumference of the entire circle, which is the length of the entire circle here, the perimeter of the entire circle. And then we can take only the portion we're interested in, which is 57 degrees. So we have 2 pi r as the circumference of our circle, but we're not interested in the perimeter of the entire circle. We're just interested in the certain angle over 360. In this case, the angle is 57 degrees. So this is going to be equal to 57 degrees divided by 360 multiplied by 2 pi, our r is 7. So if we evaluate this, that's 57 over 360 multiplied by 2 multiplied by 3.142, which is our pi, multiplied by 7. And this is going to result in 6.963 centimeters, or approximately 6.97. So our answer here is D. Question 78 says, calculate the volume of the regular 3-dimensional figure drawn above, where angle ABC is equal to 90 degrees. So we have that this angle here is a 90-degree angle, and we want to calculate the volume. So the easiest way to do this is to calculate the area of this triangle right here. And if we calculate the area of this triangle, we multiply it by the length of the figure right here, which is 18 centimeters. So to calculate the area of a triangle, we have half of the base times the height. So we have the height here to be 12 centimeters, but we do not know the base here. So if we draw out our right angle triangle here, we have this as 12 and we have this as 13. So we know that from here. So we're looking for this. So if you recall, Pythagoras Theorem says that a squared plus b squared is equal to c squared. In this case, this is our a here, 12. So that's 12 squared plus our b is the side we're looking for, which we do not know. So this is b squared. And c squared is our hypotenuse, which is 13 squared here. So 12 squared is 144 plus b squared equals 13 squared is 169. So b squared is equal to 169 minus 144. So b squared equals 25. If we look for the square root of both sides, b equals 5. So our base here is 5. So now we have our base and we have our height. So half base times height equals half of 5, which is the base, multiplied by the height, which is 12. So the area of our triangle here equals 30 centimeter squared. Now that we have the area of our triangle here, all we have to do is multiply by the length, and the length is 18 centimeters. So the volume is equal to 30 minus 18, and the volume is equal to 540 centimeter cube. So our answer here is D. Question 79 says, if sine x is equal to 4 over 5, find 1 plus cot square x over cosec square x minus 1. So let's assume that we have a right angle triangle such as this, and we're paying attention to this angle x right here. Now let's remember toi. Now we're told here that our sine x, which is the same as the opposite over the hypotenuse, is equal to 4 over 5. So essentially what they are telling us here is that the opposite of this imaginary triangle we have here is 4, and the hypotenuse here is 5. So since we know that this is a right angle triangle, we can use Pythagoras Theorem and find the remaining side here. And if we do that, we'll find out that this side here is going to be equal to 3. So now we have the complete triangle, and with that we can evaluate the other trig functions that we have here. So for example, if we have that cos x is equal to the adjacent over the hypotenuse, that's going to be adjacent is 3 over the hypotenuse, which is 5. And we know that tan x is equal to the opposite over the adjacent. So the opposite here is 4 and the adjacent is 3. So now we're requested to evaluate 1 plus cot square x divided by cosec square x minus 1. So first, let's start with cot square x. What is cot x? Now cot x is the same as 1 over tangent x. And here we know that the tan x is equal to 4 over 3. So 1 over tan x is going to be simply 3 over 4. So we know what our cot x is. So this is simply going to be 1 plus cot square x is 3 over 4 squared. Now what about cosec x? Now we know that cosec x is the same as 1 over sine x. And we know that our sine x here is 4 over 5. So what is 1 over sine x? This is the same as 5 over 4. So this is going to be 5 over 4 squared, because we have a cosec square here, minus 1. So now we can evaluate this. 1 plus 3 squared over 4 squared is going to be 9 over 16 divided by 5 over 4 squared is 25 over 16 minus 1. So for the numerator here, if we have a denominator of 16, 16 divided by 1 equals 1, times 1 is 16, plus 16 divided by 16 is 1, 1 times 9 is 9. So we have 25 over 16. And for the denominator here, if we also have a numerator of 16, 16 divided by 16 is 1, 1 multiplied by 25 is 25, 16 divided by 1 is 16, 16 multiplied by minus 1 equals minus 16. So we have 9 over 16 here. So 25 divided by 16 divided by 9 over 16 is the same thing as 25 over 16 multiplied by 16 over 9. All we have to do is flip this fraction when we change this to a multiplication sign. So 16 can cancel out 16 and we're left with 25 over 9. So 25 over 9 is our final answer, and that is B. Question 80 says evaluate 2 sine 30 plus 5 times 60 all divided by sine 60, leaving your answer in the solved form. So to answer this question, a very good trig function to know is represented by the table we have here. Now, we're not going to go into proving how these results are gotten, but it's very important that we know them, maybe in another video. Now, if we use these values, we can then be able to evaluate that our sine 30 becomes 2 multiplied by sine 30 in this equation is half. In this table is half. So this 30 degrees, this sine, that's half. Plus 5 tan 60. Tan 60 is root 3. So this is root 3 divided by sine 60. Sine 60 is root 3 divided by 2. So now we can go ahead and solve for this equation. So 2 multiplied by half, 2 cancels out 2 to leave us with 1 here, plus 5 root 3, all divided by root 3 over 2. So if this is the same as 1 plus 5 root 3 multiplied by 2 over root 3, then our new equation will be 2 multiplied by 1 is equals 2, plus 2 multiplied by 5 root 3 becomes 10 root 3, all divided by root 3. Then we can rationalize this expression. If we rationalize this expression, we'll simply multiply the numerator and the denominator by root 3 here, which is what we have here. So if we do that, we have that 2 multiplied by root 3 becomes 2 root 3, plus 10 root 3 multiplied by root 3 becomes 10 multiplied by 3, because root 3 multiplied by root 3 becomes 3. And like we said, root 3 multiplied by root 3 becomes 3. So then we can have our expression as 2 root 3 plus 10 multiplied by 3 is 30 divided by 3. Now, if we split this, we would have that this is 2 root 3 divided by 3 plus 30 over 3. And 3 cancels here to give us 1, and 3 goes here to give us 10. So our final answer is 2 root 3 divided by 3 plus 10. And that is option A here. So we've come to the end of the 2019 Mathematics Jamb past question. I hope that we've been able to learn a lot from this video, and I thank you for joining me and staying with me throughout the video. If you like this content, please subscribe to the channel and share the video. I'll see you on the next one. We'll be solving for chemistry and physics next. Thank you.